All right, here we are in chapter 11 on radicals, and we're on the last section of the chapter, 11.6 on complex numbers. So previously we've stated we can't take the square root of a negative number because they're not real numbers. So guess what? Now we work with these, and they're basically the imaginary numbers. And so we're going to work with nomenclature looking at the complex numbers, which has a real part, and the imaginary part, which is coming from that negative under the square root. So the imaginary part is going to be, the imaginary unit, and we're denoting that with just the letter I, kind of a italics I. And we know the square of I is going to be equal to a -1. And so then I squared is equal to -1 if we write it out in full. Or if we take the square root of both sides, I is equal to the square root of -1. And this is what's going to help us because, if we have the square root of a -2, well, then we know that we can say, okay, well, at -1, we can pull out, and we can get I square root of 2, and that would make it work there. Okay, and so that's going to help us when we have negative square roots. We can pull out the negative, put an I in front, and then wherever is left in the square root, we can continue on after that. So when working out problems, if we find a negative in the problem, we're going to write it as I and find the I squared. If we find that, we'd write that as a -1. So sometimes we're going to find things with a square root of -1. Other times we're going to find things with I squared, and we just have to write what was appropriate. So if we had the square root of -1, we go and say, okay, well, that's I. And if we find the I squared, we write that as the -1. Now, a complex number is a number that has two parts again. It has a real part, and so the real part is going to be our A, and we're going to have the imaginary part, which is going to be the B. Now, A and B are both real numbers, and I is the part that makes the BI the imaginary. Okay, so the BI is imaginary, even though B is going to be some real number. So, our real number in this case was the square root of 2. Maybe this had been -4, and we're taking the square root of that. Well, that's going to be an I times the square root of 4. Well, the square root of 4 is 2, so this is 2I. So here it's a number. Here, we can also have radicals. So either way, B is going to be some kind of real number, and square roots are real numbers. So what we want to do basically on all this whole section is just simplify things that have negatives in the square root. So what does this say? Well, if we have this, that's really taking and saying, well, we have a negative square root of 1 times a square root of 9. Well, square root of -1 is I, square root of 9 is 3. And so if we really write that, that would be 3I. Okay, because we usually put the I at the end of the imaginary. Now this has just the square root. We don't have a complex number. It's just the imaginary part. We could say 0 plus 3I if they said write it as a complex number, and the 0 is the real part, and then this is our imaginary part. Okay. What about this one? Well, we're going to do the same thing. We're going to pull out a -1 and then the square root of 121. Well, the square root of -1 is I again. Square root of 121, well, that's just 11. And so that's equal to 11I. Now, if they say, what is the complex number? Then you'll have to say 0 plus 11I. Again, not always will they ask for that, but sometimes they will. So you have to kind of remember a complex number has both the real and the imaginary parts. All right, so again, just working through these, we're just going to figure out what we have. So square root of 45, well, that's going to be the square root of a -1 times the square root of 45. Well, what is 45? Well, that's 9 times 5. So really what we have is the square root of -1 times the square root of 9 times the square root of 5, just to break it apart as we go down. Because we know we can find this one, that's I, square root of 9, well, that's 3. Square root of 5, well, that's still the square root of 5. And if we rewrite it in order, we'd put 3I square root of 5. Or sometimes they'll say 3 square root of 5I. But what happens there is sometimes when you're writing it in the computer, you forget to get the I outside and you end up with I under here, and the I shouldn't be under here. It needs to be outside. So that's why sometimes I like to put it there if we have a square root. That way I don't put this in just by typing, end up with the square root here. Whereas here, I can make sure the I is outside of the square root, but when you're typing, sometimes it's hard to determine and you kind of mess it up every once in a while. All right, so how about this one? Well, again, that's going to be square root of -1 times the square root of 420. Well, what is 420? Well, if we divide that by 2, that's 210. Divide it by 2 again, that's 105. So that's 4 times 105. 105, 5 is 2, 1. I think that's as far as we can go. So that's square root of -1, square root of 4, square root of 105. Okay, what do we have here? Well, square root of 4 is 2. Square root of -1 is I, so that's 2I square root of 105. And again, that's just 2, that's I, and now I just wrote it in order. And again, I'm doing the convention where I put the square root at the end. That way I don't initially put the I underneath and not realize it, and then submit it and get a wrong answer. All right. What about here? Okay, well here we're going to start multiplying. And so we're going to take a 6 times a -8. We're going to get a -48. Then I times I, and we'll get I squared. Now do you remember what we do with I squared? Well, remember, I squared is equal to a -1. So this says -48 times a -1. Well, that's equal to 48. And then that would be our answer. Okay. And that's all we have to do. We just have to remember I squared is equal to -1. We plug that in, and when you multiply, it cancels all the negatives. So guess what? Same thing here. 8 times 4 is 32, and it's a negative, so -32 I times I is I squared. And so -32 times -1, that's positive 32. All right, so this one's a little different. We have two negatives, so negative times negative is positive. 9 times 4 is 36, and then we have I squared. Well, a -1 is what that is equal to, and so we get a -36. We get a negative for our answer in this case, okay? And it really doesn't matter what we get for an answer, just as long as we follow all the rules to get to the final answer. Now here we have just a term squared. And so we have to think about what that means. Well, remember, that just says take -7i times -7i. So -7 times -7, that's 49. I times I is I squared. Well, 49 times -1 is equal to -49. So that would be our solution in that case. All right, well, what about this one? Okay, well, here we've got two square roots, both of them negative. And so I'm going to say, well, let's look at this one first. And so that's going to be a square root of -1 times the square root of 12 times, and then I'm going to have here square root of -1 times the square root of 2. Well, 12, that's 4 times 3, so I have a square root of 4 times the square root of 3. And then I have I is what -1, the square root of that is. So I'm going to have square root of 4 is 2. Then I'm going to have I, then square root of 3. And here this is I times the square root of 2. Okay, so what does that give me? Well, 2i times I is going to give me 2i squared. Square root of 3 times the square root of 2 is going to be square root of 6. Now the last thing I have to do is get rid of my I squared, which is -1. And so when I do that, it's 2 times -1 times the square root of 6, or -2 square root of 6. And then that would be my final answer. And again, nothing special. We just worked our way down on both sides here. And then when we got done, we had, this two products, and we multiplied it down and then just got to our final answer. What about the next one? Well, with the -3, there's not much we can do. Negative square root of 121. Well, if we remember way back on, I think, the first page, that was equal to 11i. So we have a -3, and then we had plus 11i. Okay, because that was square root of -1 times the square root of 121. That's I, that's 11, and so we have -3 plus 11i. And so that is a complex number. So we have the real part here, which is the 3, so that's the real part. And this is the imaginary unit. And I can maybe make that. Oops, oh well. Anyway, so that was the imaginary unit. All right, so how about this one? Okay, so square root of -4. Well, that's the square root of 1 times the square root, or I rather. negative 1. I know what I'm talking about. Square root of negative 1 times the square root of 4. That's I times 2. So this becomes 4 plus 2I. Okay. Again, real part, imaginary part. Okay, what about this one? Okay, well this one I'm going to work with the numerator first, and then I'll pull in the denominator and see if there's anything I can do. So we'll have the square root of negative 16 is the square root of negative 1 times the square root of 16. And that's I, that's 4. So what I get in the numerator is 8 minus 4I all over 4. Okay. Now I can cancel out. 4 will go into 8 2 times. 4 will go into 4 1 time. And so what I end up with is 2 minus 1 times I, or just 2 minus I. And so I could have factored out a 4 out of both of these and got the 2 minus I, and then those 4's cancel. Or if it'll cancel in both of them, then I have to keep track of how many times it cancels. And that was the 2 and the 1, and that's what I end up with as my final answer. All right, same thing would go here. We're going to have square root of negative 1 and square root of 32. Well, what's the square root of 32? Well, that's going to be 16 times 2, so that's the square root of 16 times the square root of 2. Well, the square root of 16 is 4. The square root of negative 1 is I, and so we'll have, it looks like 6 plus 4I square root of 2 over 4. Okay. All right, here we can cancel 2. I see both of those have a 2 in common as well as this, so we can cancel 2 here. 2 here would be 3. 2 here is 2, and so that gives me 3 plus 2I square root of 2 all over 2. Okay, and again, nothing special. We just took and had to break out that 32 into 16 and 2, and so that would give us 4 square root of 2. Then negative 1 gave us I, and we just carried that all down until we got that as our final answer. All right, so the next one looks like it's going to do something similar. And so it looks like we have a negative 1 times the square root of 25 times the square root of 10. Okay, square root of 25, well, that's just 5. Square root of negative 1 is I. And so it looks like we have a negative 10 plus 5I square root of 10 all over 5. Okay, well, 5 will go into this once, go in this twice, and this once. So what do we have left over? We have a negative 2, and then plus I square root of 10. Okay, everything in the denominator is gone, and we just have a real part and an imaginary part here. All right, so for the last problem, working this one, square root of 192. All right, so what is that going to be? 192 will have a square root of negative 1, then the square root of, let's see, 2 will go in here, 80. No, honestly, my brain quit working all of a sudden. So 2 goes in here, 8, and that, no, 9, that's 18, and that's going to be, 2 goes in there, 6, 96, okay. So that really doesn't help me. So 9, 10, 11, 12, it's also divisible by 3. And so 192 into that, so that's going to be 8, that's 18, and that's, oh, that's a 6, sorry. 64, that's a perfect square. So that's what we want. So we want the square root of 64 times the square root of 3. So then square root of 64 is 8. This is I. So we have 12 plus 8I square root of 3 all over 8. All right, so looks like 4 is in common. So 4 will go in here twice. 4 will go in here 3 times. That'll go in here twice. And we get 3 plus 2I square root of 3 all over 2. And then that is going to be our final answer. So this one is a little more tricky, trying to figure out what roots we want to use here. So I tried 2 first. That didn't give me anything that would work. Then I, okay, well 3 will work. So then that gave me the 64, which is a perfect square, and that's what I was looking for. And so, you know, sometimes it takes a while to find out the one you're looking for. So don't give up. Most of these that you're going to work with have something you can pull out a perfect square and then have something left over. So hopefully that'll help you with the 11.6.